All right, let's go to the very beginning here. What is another name for line L? That could be what? Speak up.
Red.
No.
Are you?
Wow.
Right?
Are you what?
It's like a line.
Ha ha ha, right. Are you with a line over the top? Could be good. You could also do what? RS. So everybody agree with that? You could also do what? SU. All right, because it's a line, it goes indefinitely in both directions. All right? Any questions with that? Pretty straightforward. All right? Name the intersection of the lines. That would be what?
S.
Yes, S. Point S. Name 3 collinear points. Now again, here in geometry, if you don't know something, usually it's because of the definition. All right, collinear just means what?
It's on the same line.
Yeah, points that are on the same line. Collinear just means points that are on the same line. So 3 points that are collinear, what?
Sorry, I just had a question. There was another definition.
Coplanar.
Yeah.
Yep. Collinear means on the same line, so coplanar probably means in the same.
Plane.
That's all. That's how simple it is. All right, but the 3 collinear points would be what? R, S, and U. That is correct. R, S, and U. You could also say V, S, and T. Lots of options here. All right, lots of options. If you're not sure, just let me know. So again, let's talk here real quickly about a few things. Is this possible? Is there a line RT?
No. Yes. RST.
Wait a minute.
No.
Yeah.
Reed, it can't like bend.
Right. So again, there's lots of answers here, but the real answer is any 2 points determine a line. Hear me out. Any 2 points determine a line. So does RT exist?
Yes.
Was it drawn?
No.
No. Okay. So again, what they're doing is right now is they're asking you from the picture, all right, what is the solution? All right, things that are drawn. Okay. In the future, they will ask some tricky questions dealing with just your ability to see things. All right. So again, now number 4. Again, the reason why this is kind of hard is because a lot of kids have trouble visualizing things. Geometry is visual, all right, which is very difficult. All right. So how many planes are there here? What do you think?
8.
8. 3. 8. Read. 8. We're pretty comfortable. Now listen, let's explain exactly what a plane is. Believe it or not, geometry, I will always be able to remember arguing with my geometry teacher about this and how silly it was. Because we have what's referred to as 3 undefined terms in geometry. Who knows what the 3 undefined terms are? What? No. 3 undefined terms. Very basic.
Line.
Yes.
Point.
Yes. What's the other one? Plane. Beautiful. The 3 undefined terms in geometry are point, line, and plane. And I used to say everything is defined using a point, line, and plane, and we really don't even know what a point, line, and plane is. See what I mean? That's what made me real uncomfortable, right? Now, why is a line or why is a point undefined? Right? When you think about it, and that's kind of what's nice about the iPad. So everybody agree, we could say that represents a point, right? And then, is it still a point?
Yes.
Right, so you see what I'm saying? The point could get what? Smaller and smaller and smaller. So some people define a point as just a location. All right, but you see what I mean? The point, we don't even know what it actually means. All right, the same thing with a line. The reason it's weird to me was that could be considered a what? That could be considered a line. Right, but what makes up the line? Right, a collection of points maybe? right? If you say it's a collection of points, but we never really defined what a point is. Do I agree with that? So bless you. It's kind of weird. All right. And then, of course, this is the symbol for what the plane is going to be like. It's usually a parallelogram. All right. So what's a plane? All right. Flat surface that extends forever. All right. In all directions. All right. Then you get into the point where how thick is it? All different kinds of things. All right. So Euclidean geometry is what we are studying. Then there's also, when you go to college, and if some of you guys want to major in math, there'll be non-Euclidean geometry, all right, which just contradicts everything there is to know about Euclidean geometry, which is very fascinating. But right now, all right, the plane is just, for example, top of your desk is a plane. A wall is a plane, all right? So now it's very hard for some people to visualize. That's why I say if all you do is just write down the answers, it's not, you're not learning the visual part of it. So you got to try to think about it on your own. So on here, this is called a hexagonal prism. The reason it's called a hexagonal prism is because the base is a hexagon, right? And there are two bases. All right, so how do I figure out how many planes there are? There's one on the top, there's one on the bottom. And then how many walls are there?
6.
6. So that's why there were 8 planes. All right, that's why there are 8
6, 7, 8.
planes.
I just thought because like
You
you
put-
said shown, and I thought it was like
3,
one of
7,
those-
8.
Yeah. Now again, this is why I'm trying to tell you. I'm really not going to try to trick you. You understand what I'm saying? Right? So again, I understand why you said 3. All right? But again, the object was for you to be able to see the whole thing. All right? Again, that's probably not the best way of saying that. I probably should, for next year, just go ahead and eliminate that. How many planes are in the figure? I think that would be better. All right, thank you. All right, so here we go now. The length of UW, or find the length of UW if W is between U and V. All right, so now what I want you to do is just get in the habit of, for us right now, is we're going to draw in that segment UW, and then it says, I'm sorry, it was find the length of UW if W is between U and V. All right, so this actually is coming over here, and this is V right here. All right. Now, one of the things that we learn in geometry, there's just things you have to know based off observation. There's no way to prove things. All right, and one of the things that we do is we say, and I want you to make sure you understand this, the segment addition postulate. Now again, why is it called a postulate? It's called a postulate because it's something you have to accept as true. Believe it or not, I cannot prove this to you. All right? It's just based on observation. And I used to tell my geometry teacher it's just another one of those common sense things. All right? And what is a segment addition postulate? In this example, we would say that UW plus WV must equal what? UV. Everybody see that? That's the segment addition postulate. Again, you can't prove it. You have to accept it as true. All right, which to me is kind of common sense. All right, so let's look up here and see how the segment addition postulate helps us. It says that UV is 16.8. So I do this, 16.8. And then VW is 7.9. Everybody agree? So that's pretty simple. I know everybody can do that. So then UW is how much? 8.9. Easy as that. Any questions or concerns, right? Pretty easy. All right. Now here, for question number 6, it says RS is 24. So what do I know is true? Somebody write the equation. I'm listening. I really like that. RT plus TS equals RS. And that is called, again, the segment addition postulate. Simple as that. All right? So now let's go ahead and write the equation. Somebody tell me. Right. Now, again, everybody listen to me. Guys, I just want this to be mental math. Everybody should be able to look up there, no math. You should just say, obviously, x is equal to what?
3.
Everybody happy with that? X equals 3. Practice that. Okay? Now what? I need to find anything? Find the value of x. Nope, that's it. Sometimes they'll say find RT. Sometimes they'll say RS. So when you take your test, you have to do the problem. Then you have to do what? Actually answer the question. Does everybody agree with me on this? Everybody understand me? Because the answer could be 3. The answer could have been 14. All right? Everybody good? Very easy. All right, now find the length of LO if M is between L and O. So again, I would draw it just to make sure. M is between L and O. And now once you draw it, it's kind of easy to see. So you would say what? LM, which is what?
7x minus
And then MO, which is?
14.
Must equal
10x minus 7.
10x minus 7. Everybody happy with that? All right, so now let's see if we can do the mental math. So 3x, right, is equal to what? So x is equal to what?
4.
X is equal to 4. Now, if you put x equals 4, then you're probably going to be what? Probably going to be what?
Incorrect.
Incorrect. Because this is one where you have to go back. Always, do me a favor, always go back and read the problem. Find the length of LO. Right? So then we can just plug it in for here, correct? So my answer is what? 33. Any issue with that? That's very easy. All right, stay with me. Here, what does this symbol right here mean? Equal, not exactly. It means congruent. So what's the difference between congruent and equal? What's the difference between congruent and equal? Shapes are what? Congruent. Lengths are what? Equal. So when you're describing a number, you would say what? Equal. When you're describing shapes, you say they are what? Congruent. If they are congruent, they are what? Equal. And if they are equal, they are what? They are congruent. All right? And that we call, in math, we say that's like the definition of congruent. All right? That's the definition of congruent. But technically, which is what mathematicians are, we describe shapes that are the same, congruent, and the sizes are what is equal. All right, so we understand that. All right, so if they are congruent, if PQ is congruent to RS, that means that PQ is what? Equal. So now, let's go ahead and do, again, 9x minus 7 equals what? 29. And so again, we would just say x equals 4. And when we say x equals 4, we figure out what the question is. Again, I'm trying to stress because last year, every year, people missed 3 or 4 questions because they didn't answer the question. All right? The biggest mistake on the test is you don't answer the question. All right? You solve the problem and think you're done. You always got to go back and answer the question. So x equals 4. Everybody good with that? All right, number 9. Which of the following is not undefined? Bisector. All right. Point, line, and plane are the undefined terms. All right, now, midpoint just means you're in the what? Middle. You're in the middle. Does everybody agree? And if you're in the middle, you are an average. All right, that's how I remember midpoint. So the formula for midpoint is, and this is super important, it's on all standardized tests, midpoint. All right, so we have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That is the midpoint formula. All right, whenever you want to find where you are, if you're in the middle, is you are the average. Any questions with that? All right, so the midpoint here would be what? Tell us.
4, 7.
Somebody said 4, 7. Does anybody agree with that? Right? Just the average. X plus x divided by 2, y plus y divided by 2. Everybody good? All right, let's check out the next one. Find the coordinate of D if E is the midpoint. All right, now I'm going to show you the easiest way to do these. All right, no real math. All right, so here we go. I want you to draw the line. And E is the midpoint. If we have C and D. All right, and C is -3, 4. E is 0, 1. And that's right in the middle. So everybody should be able to tell me that D is going to be what? Real quick, tell me.
3, -2.
3, -2. How'd you do that?
It's just because the y was going down by 3 over time and the x was going up by 3.
Couldn't have said it better myself. That's exactly how you should do it. Exactly how you should do it. All right, so pay attention now. Make sure you heard him correctly. If you start at -3 and you end up at 0, that just means you walked how many units? 3 units. If you're in the middle, you need to walk another what? 3 units, which will take us to what? 3. Then you started at what? 4, and the middle was 1. So that means you went what? Back 3 units, correct? So if you're in the middle, you got to go back another 3 units. So that's where we got the -2. Anybody have any questions with that? I'm agreeing. It's simple. All right, here we go. Exterior. So let's highlight, and this stands for the measure of angle RTS. So I'm going to draw RTS. So there's that angle RTS. So where would, or what point would be in the exterior? Tell me.
U.
Or
P.
U or, no, not P. U or V, right? U or V would be in the exterior. So let's highlight that and make sure you're good. Exterior, exterior, correct? P would be where?
Interior.
Interior. All right. Okay, underline bisect. You should know what that is. Bisect just means what?
Yes. Line.
Tell me what it means.
Bisect means a line crosses through another line.
Crosses through what? So if I bisect you, what am I going to do?
You want to
Cut you right in half. Cut you right in half into 2 equal parts. That's what bisect. You can be an angle bisector. You can be a segment bisector. All right. If you're an angle bisector, you cut the angle in half. All right. So let's say I have angle TSU. So now the point here we're doing is we're drawing these angles. All right. You're practicing. All right. You're visualizing. And some of you are really good at the visualizing, so it's not really that difficult. And some do not visualize that well. All right. So my objective right now is to make sure that you're visualizing correctly and that you learn how to draw the shapes and draw the figures properly. So when I say the measure of angle TSU, what we're going to do is we're going to have this angle TSU. Notice that S is the vertex. The letter in the middle is always in the middle of the angle. That's the vertex. Then it says that SU bisects, it bisects, see, that's what I'm saying, you got to be careful. So I'm just going to move this out of the way. Move this over here so I can see it a little better. All right, so I didn't read it too good right off the bat. So find the measure of TSU if SU bisects TSV. So really what I have to do is I have to come over here and draw V. Does everybody agree with that? And I'm trying to draw V so that when you say SU bisects TSV, this is how you represent that. Now, can you understand that SU bisects TSV? Everybody see that? SU bisects TSV. So what's true about TSU and USV? What's true? I'm going to say it one more time. Look up. What's true about TSU and USV? Those angles. Tell us. Collinear means they're on the same line. Tell me, Ava. They are equal. Thank you. All right, they are equal. So this is what this tick mark represents. This tick mark and this tick mark represent those two angles are equal. And if those two angles are equal, then we know that SU did what to TSV? Bisected it. We just cut it in half. That's all we did. All right, that's all we did. Now, this is a good time to bring up, before we talk about the segment addition postulate, now is the time to bring up the angle addition postulate. So somebody define the angle addition postulate using this information right here. What would the angle addition postulate say? Come on, speak up. Say it.
TSU plus USV
You're brilliant.
equals equals TSV.
You're 100% correct. All right. So we would say for the angle addition postulate, angle TSU plus angle USV equals angle TSV. That is the angle addition postulate. Does everybody agree it's the same as the what? Segment addition postulate, except we're talking about what now? Angles. And again, remember why it's called a postulate is because you have to what? Accept it as true. You're accepting it as true. No proof involved. Everybody good with that? All right, so now I'm going to erase this for a second, and it says that STU is 4y plus 11. It says, I'm sorry, TSU. So this is 4y plus 11. And then it says USV is 6y plus 5. So what's true about those two angles? They're equal. All right, so we're just going to come say 6y plus 5 is equal to 4y plus 11. And so, come on, y equals what here?
3.
I think y equals 3. Good? Anybody have a problem with y equals 3? Now, of course, that's probably not the answer, so I have to go read the question. Find the measure of TSU. So what do I do? Plug 3 in. And when I do that, I get what?
33.
What do I get?
20.
I think 23. All right, you measure angles with what? Degrees. 23 degrees. Everybody okay with that? And so then what would the measure of USV be? 23 degrees. And what would be the measure of TSV? 46 degrees. Okay, simple, simple, simple. All right, very easy. All right, now the distance formula. All right, does anybody remember the distance formula from last year? Distance is equal to what? That would be slope. Distance formula, let's do it. And then I'm going to show you something you should know. x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. Everybody good with that? And then I'm going to show you how we got that distance formula. Very easy. All right. So let's go ahead and do the math here. All right. Now please be careful. Subtract the x's. When I subtract the x's, what do I get? I don't think so. 6, right? And then when I square it, I get what? So the first thing I want everybody to do is I want you to say that's 36. Now, Ava, do you see how I got the 6? Because it was what? It's either -2 minus 4 or 4 minus -2. Okay? So I need everybody to subtract the y's now. What do I get when I subtract the y's? And when I square that, that becomes what? I think it's 16, right? So when I subtract, I get 4, right? When I square, I get what? 16. Come on now, you guys got to remember with me, if you're not sure about something, the longer you wait, the harder it gets. All right, is everybody okay with that? And then that just becomes the square root of what? 52, right? And because we remember everything I taught you last year, everybody's going, well, that's obviously 2 radical 13. Right? Because 52 is what? 4 times 13. And then the square root of 4 is what? 2. So it's 2 radical 13. Good? Lots of review stuff.
We just leave it at that, or would we?
Yes, 2 radical 13 is the answer. 2 radical 13 is the answer. What?
Let's use the y2. I mean, never mind.
You okay? All right, good. Here we go. Number 15. If measure of angle 1 is 7x plus 6 and the measure of angle 2 is 8x minus 6, find the value so that x, so the value of x so that P is perpendicular to Q. All right? So, yeah, I think they left something off here.
What's P and what's Q? What's P
Right,
and
so
what's
here's
Q?
what they, here, listen, here's what they meant to say. They meant to say something like this. Here's 2 lines that intersect, all right? If this is line P and this is line Q. Yeah, because I'm not sure. Wait a minute. Just look, I'm looking up here. I don't even see that. So again, here we go. I'll show you what they mean. So if 2 lines are perpendicular, that means these angles right here are what?
Opposite, right.
Right angles. That's what perpendicular means. Perpendicular means 2 lines that intersect and form a what? A right angle. Everybody with me on this? All right. So that's the symbol that we're going to use for right angle. All right. So now, if we know that those lines intersect at right angles, then that means that they are perpendicular. Now, I think what they meant to put up here was this right here is angle 1, and this right here is angle 2. All right. So again, there's a mistake on that one. So just draw the figure. All right. And usually they don't even put the angle symbol in there. They would just put this is a what? This is a 1 and this is a 2. So what's true about angle 1 and angle 2? I don't think they're equal. Angle 1 and 2 are not perpendicular. Well, it looks like they bisect, but let's do this. Thank you. They add up to 90. All right. Is it possible they could be both 45 and 45? Yes. But we don't know that. We're just saying that angle 1 and angle 2 have to add up to what? 90, because the lines are perpendicular. Everybody with me on this? So we would say on here, we would say, well, just in interest of time, we just say what? 13x, 14x, no, 15x is equal to what? 90. Is everybody good with that? And so x is what? X is 6. Well, it's just asking to what?
Find the value of that.
Find the value of x. But they could have said, what's the measure of angle 1? They could have said, what's the measure of angle 2? What?
So how do you get a 15x?
I added 7x plus 8x.
What about the 6s?
Just cancel out.
Oh, they cancel out.
Plus 6 and minus 6,
Oh,
right?
I thought it looked like it was -6 up there. It looks like it's -6.
Yes.
How are they not both equal?
Okay, let me show you this. That's a good point right there because I didn't do a very good job explaining it. That's why. Look right here. Now they don't look equal. You see what I mean?
Yeah.
It has everything to do with your drawing. That's why I try to tell kids when you make your pictures up, if they don't say things are equal, if you accidentally make them equal, your brain will think they're what? Equal, and then you'll make a mistake. So if they don't tell you you're equal, try not to make them equal. All right? Okay, supplementary. What do we mean by supplementary?
They add up to 180.
They add up to 180. All right? So again, the sum is equal to 180. All right? I don't care what the answer is. That's too easy. All right? If x equals 5, find the perimeter of a rectangle whose length is and width is. What was that answer? I don't even want to do that problem.
442.
Somebody said 86. Somebody said 400 and what? I'm okay with that. 400 and what?
42.
442. What else? Charlotte, what'd you get?
82.
Good. 82. Somebody else. 86. Okay, so now remember, sometimes you get confused with perimeter and area. Remember, area is the one that you multiply. Perimeter is the sum of the sides, correct?
Oh,
So if x is 5,
I got the area, guys.
right, that's okay. So if x is 5, then the length would be what? 20, is that right? 26.
Yeah.
Yeah.
And the width would equal what?
17.
17. All right, so the perimeter is the sum of the length and width times 2. So the easy thing to do is to add that, which is 43 times 2, which is 86.
86, yes.
All right, perimeter is equal to 86. All right. Okay, so now some of you should have not known convex, so you just looked up on your computer or your iPad, what does convex mean? All right, so it is a convex pentagon. All right. What is the effect on the perimeter if each side is doubled in length? What would that do? If each side is doubled, what would that do to the perimeter?
Double it.
It would double it.
Yeah.
All right, it would double it. All right. And if you weren't sure on that, you could have drawn that shape out. All right, it would definitely double it. Okay, so let's see if you're good at reflections. All right, so I want everybody to graph this out. I want everybody to graph -2, 3. And then 3, 1. And then 0, -4. Then we're going to draw this triangle. All right, does everybody see that? Now I think reflections are very simple. All right. So I'm going to change. Just to make sure you're okay, you have to understand that this right here is the y-axis, right? So when you reflect something over the y-axis, all right, what is actually going to change if you reflect over the y-axis? Does the y change? The x changes. Right, so let's see what I mean by this. Okay, now I'm going to blow it up and I'm going to have you look real quick because I do think it's important. Look right here now. All right, so if we're reflecting over the y, that means this distance is how much?
2.
So if I reflect it, it's going to be what?
2.
2 on the other side. All right, so this is this new point right here. Everybody agree? Now what you're supposed to recognize when you reflect something on the y value or on the y-axis, what is actually changing again? The x-coordinate change, and the y stays the same. So what do you think happens when you reflect over the x-axis? The y changes. And if you visually think about it, if you're here and you reflect over the y-axis, the y value is staying the same. This is what I'm trying to show you about visualizing now. And if you reflect over the x-axis, the y is what's moving and the x stays the same. I want you to know that. All right? Everybody okay with that? Understanding? All right? So now this point right here, which was -2, 3, A prime would be what? If I reflect over the y-axis, what would it be? And A prime is just the A that's been moved. 2, 3. Thank you very much. B prime would be what? Say it. -3, 1. Now remember what you just told me. That's what I'm trying to say. Guys, I really want to get off of, you know, if somebody makes a mistake, you're jumping on it. I don't care. You're going to make a lot of mistakes with geometry. It's different than things you've done. All right? Some people visualize better than others. It's a difficult thing until you get used to it. All right? So we just said when you reflect over the y-axis, the x value changes. The y value stays the same. So now I'm going to ask you about the c coordinate, and everybody in here should be able to tell me what the answer is. Remember, you're not writing the answers down. You're telling me what the answer is. All right? So c prime, everybody should be able to tell me that that's going to be what? 0, comma, -4. All right? And which obviously would make sense if I blow this up and I were to reflect this over that axis. How far is it from the axis? 0. So it's not moving. All right? Is everybody with me on that? So this becomes what it looks like. Watch me. 1, 2, 3. 1, 2, 3. Here we go. All right? And it's kind of hard to see, but if you draw this pink end, this pink triangle, that's the reflection. Now, part of the reason why it's hard to see is because I drew those in. And I drew this in. Now, your brain should be able to see, yeah, that's been reflected. Again, a lot of people think reflections and rotations and translations are difficult. They're difficult if you don't have any idea what you're doing. Super easy if you understand. All right? I think reflections, rotations, and translations are very easy. All right, so let's move on. The volume of a pyramid is 27 cubic centimeters, and its height is 6 centimeters. Find the area. So I'm sure everybody in here forgot the formula for volume of a pyramid, because you had to think back to 6th grade, 2nd semester. And what's the formula for volume of a pyramid, Charlotte? Do you remember?
Yeah, volume equals 1/3 length times width.
Beautiful. Length times width times height. If you didn't know that, you were supposed to do what?
Look it up.
Look it up, guys. If you want to be brilliant, when you don't know something, you got to look it up. And you're not going to know a lot in here. All right? Because some of it's not common sense. All right? I'm going to tell you something, you're going to forget it, then you got to look it up and look it up and look it up. All right? The more you get in the habit of doing that, the better you'll be, your grade will be. All right? So now the volume is what? 27 equals 1/3. All right? Now, what would be the area of the base? The area of the base would be length times width. You agree with that? So I'm just going to write B, and then it said the height is what? 6, right? So does everybody see that the area of the base would have to be 13.5 square centimeters? Anybody have any questions with that? Come on now, that was kind of hard actually.
Yeah,
Come on, speak up then. If you don't know something, just speak up. All right?
So did you just divide 27 by 2 technically?
Well, what's 27 divided by 2? Then that's what I did. Now, why did I divide by 2? Because 1/3 of 6 is what? 2. So 2 times the base has to be what? 27. So that means the base had to have been 13.5. Agreed, guys? All right. Again, I'm going to ask you about formulas. If you don't know the formula, you're allowed to do what? Look it up. All right, look it up. A hexahedron. All right, now I'm sure some of you didn't know what a hexahedron was. Right? So you should click Google hexahedron. All right? What is the shape of each face?
Triangle.
A triangle. Right? It's a triangle. Now do me a favor. Click to Safari and look up hexahedron and look at the figure and then tell me what the shape is. What is it? What's the shape of the face? Triangle. Now come on, just calculate how long did that take you to look that information up. No time at all. No time at all. It's much better to do that on your own than come here and listen to me say it's a triangle. All right, that's what I got to convince some of you. Don't be lazy. All right, geometry is very simple. It's very simple. But there's a lot of what? Vocabulary that's annoying. All right? Here we go. Which point is coplanar with A and C? That would be... Oh, boy. This is kind of interesting. All right? So, hold up. Listen to me for a second on this. This is where it's a problem. All right? So, I need everybody to understand this. Is that us?
Yeah.
All right. So, on Monday now, we're starting in the book with the review. All right? But I'll finish this up on Monday. All right, I'm going to finish going up over all this on Monday. Super, super important that we go through this.
Should we
Finish it. ERBs, all of it on Monday. I'm going to take a look at what you did. Good job for today.
Thank you.